Every SAP transaction communicates with users through messages. A green status bar saying saved after a posting. A red error pop-up blocking incorrect input. A yellow warning before a dangerous operation. These messages all come from message classes, a centralized, translation-ready store of numbered message texts. In this module, you will learn to create your own message class, use the message statement correctly in every execution context, link messages to exception classes, and build structured persistent logs that your users and support team can query in SLG1. By the end, you will create a message class in SE91, use all 6 message types correctly, supply placeholders, capture message text with message into, issue messages appropriately in OO methods and baddies, link messages to ZCX exception classes, create an application log with BL_LOG_ function modules, and view results in transaction SLG1. The objectives are arranged from foundational to operational. By the end, you will have everything needed to communicate with users and audit what your code did. This first half of the module covers the messaging foundation message classes maintained in SE91, the message statement and its 6 types, placeholders in 1, 2, and 4, capturing text with message into, and the context-specific rules for using message inside form routines, class methods, baddies, and function modules. By the end of this section, you will have the building blocks every ABAP program uses to communicate status, warnings, and errors back to users in a translation-ready and reusable way. Transaction SE91 is the message maintenance transaction. Create a message class with AZ prefix name, up to 20 characters, and a short description. Inside the class, each message has a 3-digit number from 000 to 999 and a short text of up to 72 characters. The short text can contain up to 4 placeholders, and 1, and 2, and 3, and 4. Using explicit numbers like and 1 and 2 rather than bare ampersand signs ensures that translators can reorder the placeholders correctly for languages where the grammatical word order is different from English. The message statement references the class and number compactly. Message S001, open parenthesis, ZACME_messages, close parenthesis, with LV__ number. This replaces and 1 in the short text with the value of LV__ number at runtime. 1 message class per application area. This makes it easy to maintain and translate all messages for a business domain in one place. There are 6 message types. S for success shows the text in the status bar at the bottom of the screen and continues immediately. No user action required. This is the most common type for confirmation messages after a save. I for information shows a pop-up with an OK button. The user must click OK, then processing continues. W for warning shows a pop-up but lets the user press enter to proceed anyway, or back to return and change something. E for error in a report stops the program and shows the message. In a dialog PAI module, the screen redisplays with the error highlighted. The user must fix the error before the flow can continue. A for abend terminates the entire LUW immediately and should almost never appear in custom code. X is an internal SAP type that produces a short dump. Never use it in customer development. The wrong type creates serious user experience problems. Using E where S was intended blocks the screen. Using S where E was intended means errors silently pass by. Always test your message types interactively before releasing. Placeholders and 1 through and 4 are positional. They map to the 1st through 4th parameters in the with clause of the message statement. Use explicit numbers rather than bare ampersand signs when message text has multiple placeholders. This ensures translators can safely reorder them without breaking the logic. The message into LV_text addition captures the formatted message text in a variable without displaying it. This is essential in 3 situations. In OO methods where displaying an error directly can have unpredictable effects. In baddie implementations where displaying errors in a post-commit method can dump the calling transaction. And when building return tables for BAPIs or application log entries. After any message statement, including message into, the system fields SYMSJID, SYMIGNO, SYMSGTY, SYMSGV1 through SYMSGV4 are set immediately. Read these right away. The next message call will overwrite them. Use SYMSJID and SYMIGNO to construct BAPRET 2 rows or BAL log entries with full message metadata. A quick recap of the key numbers behind message classes. 6 message types: A, E, I, S, W, X, each with different display and flow behavior, so always choose the type that matches the impact on the user rather than the type you used last time. For placeholders per message and 1, and 2, and 3, and 4, passed via the with clause. Use explicit numbers, not bare ampersand signs, so translators can reorder them safely. 72 characters is the maximum length of a message short text. Keep it pithy and move longer explanations to the long text accessible via F1 help. 999 is the maximum message number per class. 3-digit numeric IDs from 000 to 999. Group related messages by application area so the class itself documents the business domain. In a form routine or report, direct message E is fine. It ends the report. In a class method, avoid direct message E. The behavior depends on the execution context, which the method cannot know. Instead, use message E into LV_text. Then raise a typed ZCX exception with LV_text as an attribute. The caller handles the exception and decides what to do with the message. In BADI-posted methods, those that fire after data is already committed, never display errors or raise exceptions. The PO has already been saved. Your code is a notification hook. Any exception from this method propagates up and dumps the calling transaction me21n. Instead, use message E into LV_text, capture the SY message asterisk fields, and write them to the application log using BL_log_msg_add. In function modules, the message raising exception syntax combines the message data with the exception. The caller's exceptions clause maps the exception to a SY subarg value, and the SY message asterisk fields contain the message details ready for display or logging. The second half of the module covers persistent structured logging, the application log or BAL framework, together with 2 patterns that build on it, linking ZCX exception classes to message class entries so exceptions carry translatable text, and a reusable logger wrapper class that makes BAL injectable for unit tests. After this section, you will have an end-to-end pattern for capturing operational events and surfacing them to support teams via transaction SLG1. The application log framework, BAL, provides persistent, structured logging that survives program sessions and can be queried by authorized users in transaction SLG1. Unlike write statements that disappear when the report ends, BAL entries persist in the database until the retention period expires. The setup has 2 steps. First, in transaction SLGO, create a log object with a Z name and define subobjects for different categories within that domain. Second, in ABAP, call BL_log_create to open a new log handle. Then BL_log_msg_add for each message you want to record. Then BL_db_save to persist the log to the database. The log is then visible in SLG1 filtered by object, subobject, user, date range, and transaction code. 3 patterns extend BAL beyond write and save. First, use BL_DSP_log_display to show the log in a pop-up from within your program, and BL_db_load with a filter structure to read historical entries back into memory for analysis or reprocessing. Log entries have a problem class: 1 for important errors, 2 for warnings, 3 for information, 4 for details. Second, ZCX exception classes in C12 can link their text IDs directly to message class entries. On the Text tab of the exception class, define a text ID and map it to a message class, message number, and attribute to placeholder mapping. When raisException fires with that text ID, the get_text method on the exception automatically resolves the message class entry with the exception's attribute values substituted for the placeholders. This gives you typed exception handling with translation-ready message text. Third, a thin wrapper class encapsulating the BAL function module calls makes the logging injectable and testable. The wrapper implements the if_logger interface from C08, so existing business logic that uses if_logger can transparently gain BAL persistence just by injecting the new implementation. Unit tests inject the mock logger and never touch the real BAL framework. Message classes in SE91. Z prefix, 3-digit numbers, and 1 and 4 placeholders. Message types: S status bar, I info pop-up, W warning proceeds /back, E error blocks, A terminates, X never use. Message into LV text captures without display, SY message asterisk set immediately, read before the next call. Context rules. Forms, direct message OK. Class methods. Message into then raise exception. Baddie posted, message into then BAL log only. FM's message raising. BAL. SLGO object setup. BAL _log create. BAL _log MSG ADD. BAL _db save. View in SLG1. Wrapper class behind if _logger for DI and testability. Your lab creates message class ZACME MSGS initials, builds the ZCL logger wrapper class, and writes a program that logs PO audit events to the application log for viewing in SLG1. Good luck, and I will see you in C13, authorization objects.